Hey everyone. So you're welcome to another lecture series on the sequences and series. Today we'll particularly look at some of a geometric or exponential sequence. And maybe if we have time, we'll start looking at application as well. So let's begin. So we'll start looking at some of a GP or exponential sequence. Exponential sequence. All right, so let's begin. This one depends on this one depends on um the nature of the common ratio. So this is not like AP. This is not like arithmetic progression where you have a straightforward approach um to finding the sum. For geometric progression, you have to look at the common ratio. If the common ratio is greater than 1, if the common ratio is greater than 1, the approach is different. Okay, and I believe you know what the common ratio is, right? I believe you know what the common ratio is.
Yes.
Okay, all right. So let's take a look at that. Yeah. So when the common ratio is greater than 1, to find the sum, it's equal to a the first term into bracket r exponent n minus 1 all over r minus 1. And when the common ratio is less than 1, it's this area that's going to change, this area. Let's see how it goes. So Sn is equal to a into bracket 1 minus r exponent n all over 1, all over 1 minus r. Just observe. So is that please that's going to change. And of course, it's affect the denominator too. Are you ready? Let's take some examples. So, example 1. The third term of a GP is 10, and the C term. Do you have a prefect in the room?
Yes.
Who is a prefect?
Andrews.
Is he the only prefect in the room?
And patients.
And who appointed them? Because I don't remember doing that.
Then please, we are not prefects. So we did it ourselves.
I see. So I would appoint.
Okay, okay. So we are not prefects.
So I'll appoint based on stature and command. Yeah, because the prefect should be able to command or lead everyone. Wouldn't want someone who is sober here and there. So I'll take advice from the office staff as well. I'll get their
Okay.
recommendation
Yes, sir.
for the first term and the sum of the first 16. Okay, are you ready?
Yeah.
So the third term of a GP is 10 and the C term is 80. Find the common ratio, the first term, and the sum of the first 6 terms. Oh no. I'm just wondering why this should be the first question. Um,
Oh,
you finish, but we're not gonna
okay,
solve this one yet.
okay.
We'll solve this first. Find the eight, find the eighth term and the sum of the first 8 terms of the exponential sequence. This is exponential sequence. All right. Shall we begin? Let me know if you're done writing. Okay, my records indicate that the attendants are we have Charity, Rhoda, Dennis. Who else? I don't know
Patients.
anyone called Dennis. It's Benes. Yeah, Benes. Patience. Okay. Can we move on? All right. All right, so I want us to look at the second one. Like I said, this is not rocket science. This is simple logic. Okay. The thing we're learning is sum, right? Sum of the first items of an exponential sequence. And I told you sum would be having to add from having to add half to one to two to four. That's what sum is about. So if I ask you to find the sum of the first three terms, it's half to one, adding half to one to two. Do you get it?
Yes, sir.
And you can simply do this from your calculator. There is a problem with the attendance. Oh, Charity. Okay. Yeah, she's there. Okay. Yeah, so now. Now, the problem comes when I've asked you to find the sum of the first 250 terms. That means you have to identify all the 250 terms and you take your time to punch them on the calculator and then add them, right? This is where the formula comes into place. So the formula helps you generate the total of the first 250 terms without having to look for the terms and then add up. That's what the formula does. So we're going to put that into practice. So the first question is we have to find the E. We are solving number two first. Find the E term and the sum of the first E term.
Sir, please, can you wait a bit?
Okay.
Read fast. I think some may do. That's a big.
All right. Find the E term and the sum of the first E term of the exponential sequence. So to find the E term, I think that's already discussed. Let's generate the formula first. Remember this an AP. Sorry, this is a GP, geometric progression. And to find the n term is AR exponent n minus 1. Now we need to find the R. So R will be equal to U2 minus what? U1. So that will be equal to 1 minus what? Half.
It's two vowels. So it's U2 divided by U1.
Say that again.
U2 divided by U1.
Oh yeah, right. This was for AP. U2 on U1. So we have 1 divided by half.
Yeah.
Or maybe we can put it this way. That'll be 1 times 2 over 1. Because you have to change the division to multiplication and you have to reciprocate the number. So that'll be 2. So what's that? What's that? So the A term, U8, will be equal to 1 over 2. R is 2. That'll be 8 minus 1. So you have 1 over 2 times 2 exponent 7. 1 over 2 times 2 exponent 7 is 128. Now, half of that is what? 64. So now you know the 8 term. Now, so it says find the 8 term. What was the next question? Charity. Read from the board. What's the next question? What's the next question?
You can see.
You can't see the question on on a board. So what I'm solving, you can't see anything. Is that what you're telling me? I need a response. The solution, you can't see anything on the board.
That is you can see.
So what's the next direction?
The sum.
So we are now finding for the sum of the first
Eight
eight
times.
All right. Now, to find the sum, the formula is dependent on the nature of the common ratio. And I said if the common ratio is greater than 1, when we say something is greater than 1, meaning 2, 3, 4, 5, 6, right? Or is greater than 1. There is a way to go about that. So if it's greater than 1, then to find the sum, Sn is equal to a into brackets r exponent n minus 1 all over r minus 1. Let's pull up the formula to see if we did the right thing. Yeah, so um but what are we asked to find? The sum of the first 8 terms. So S8 will be equal to the first term was half, if you check. So that'll be half to bracket. R is 2 exponent n minus 1. No, n now is 8, sorry. Right? All over 2 minus what? 1. So that'll be 1 over 2 into bracket. 2 exponents, 8 is what?
2 exponent 8, 1 to 8.
256 minus 1. All over 1. So you have 1 over 2 into bracket, 255. All over 1. Okay. Well, it's the same as, okay, so let's see, half of 255. It will be 255 over 2. So this one will be equal to 255 over 2 for the top over 1. But anything over 1 is the same as that. So there's a sum. There's a sum. You can choose to put that in a decimal if you want. So, or 127.5. And you see this because in the sequence there is a fraction already. The sequence is half 1 over 1, 1, sorry, half 1, 2, 4, and you don't know what goes on. I'm showing the subsequent one, there may be fractions as well, but even if there isn't, the fraction alone should tell you why the sum is yielding a fraction or a decimal. Is there anyone in the class that is lost? Is there anyone in the class that is lost? Okay, let's continue. Can we go? Let me know if you're done Then we can look at this question now.
The common ratio is.
Say that
They
again.
are coming.
Stephanie,
I
the
thought you
common
said you are
ratio.
done.
Yeah, please, yes.
So common
Akaba.
difference. What
mean,
is
yeah.
what's the interjection? Who is that? What's the common difference? The question says, no, there is nothing like common difference here. Common ratio. Yeah, it's 2. And then what's the first thing?
5.
Say
5 over 2 or 5.2 or 2.5.
No, wait, hold on. 2.5, yeah. And then what's the 8, 10?
Yes, 6.
Say the
The
sum
6
find
thing.
Yes.
no the sum of the first systems.
Yeah, so what's the sum of the first 6 terms?
157.5.
Take a shot of your solution. One should present the solution on the board. Take a picture and send it to me now. Don't waste time because I'm going to application now.
Yes.
That will end the topic. I'm waiting. Let's take a look at the solution from the student. The organization is actually so. All right. The So the question is, the third term of a GP is 10 and the C term is 80. Find the common ratio, the first term, and the sum of the first 6 terms. So that we are looking at 3 things: the common ratio, the first term, then the sum of the first 6 terms. In fact, if you don't find the common ratio nor the first term, you can't even find the sum. Okay, so let's see. So they said the third term is yeah, so she wrote the formula AR exponent 3 minus 1. So U3 will be AR exponent 2. But the third term from the question is what? 10. Yeah, so U3 is equal to 10. Oh, do you see my screen entirely? Let me do this. Oh, I thought I was even sharing everything. Yeah, I'm sharing the full screen. So what's the problem? Do you see? Do you see the projection of their solution? Your own solution. Do you see it?
Yes.
All right. So U3 is equal to AR exponent 3 minus 1. U3 is equal to AR exponent 2. By U3 is equal to 10. In the question, they said the third term is 10. So now AR exponent 2 will no longer be equal to U3, but it will be equal to its replacement, which is 10. Now, they talked about the third term and the third term and the seed term. So the seed term, U6 is equal to AR exponent 6 minus 1. U6 is equal to AR exponent 5. But U6 is equal to 80. All right. In the question, they said the seed term is 80. So now AR exponent 5 is equal to 80. So you have 2 equations now. Wow. So she chose to divide. Normally, if you divide it, make it easier though. So she divided equation 2 by 1. So equation 2 be AR exponent 5 over equation 1 is AR exponent 2. Now, equation 2, AR exponent 5 is equal to 80. So 80 divided by equation 1 is 10. If you do it well, A will cancel A. R2 will cancel 2 R's from the R5. You'll be left with R3. It's equal to 80 divided by 10 is 8. Then now you left with R3 Girl, I can't see what you did over there. What you
Say I'm
have
thinking.
there to establish a root? Okay, R3 is equal to 8. Oh, introducing cube. What you've done is square root. This is square root. You are seeing introducing cube root and you've done this.
But let me there. These symmetry.
There is no 3. It's square root.
But the three. But then R3.
Where is the 3?
You forgot to bring the
So it's wrong. It's not about you forgetting. It's wrong. What you've done is wrong. It's wrong. It's simply wrong. You have R exponent 3 is equal to 8. So you introduce a cube root, not a square root. Cube root of R cube is equal to cube root of 8. So what you've done is wrong. Now this cancels that. R is equal to what's that? I think
The marker is not clear. Take a clear one.
so that portion is wrong. You have to fix it. Are you listening?
Yes, sir.
Now put R equals 2 into equation 1. Equation 1 is AR exponent 2 equals 10. I think the reflection of the light. Can be all right. I think you replace the R as 2, so to be into bracket 2 squared equals 10. So 2 squared is 4. So that'll be 4e equals 10. You divide by 4, you divide, yeah, so a will be 5 over 2. Then now to find the sum, R is greater than, you have to indicate that R is greater. So yeah, before you introduce the formula, indicate that R is greater than 1. So it influences the formula you have to use. You don't just go to the formula. I've done 2 corrections here. So Sn will be equal to a into bracket R exponent n minus 1 all over. Okay, so S6 equals 5 over 2 bracket 2 exponent 6 minus 1. All right, 64. Okay, right. Yeah, so that portions I corrected you. You have to fix it. Above all, if you fix that, then it makes it right. Okay. Can we move on? Can we move on?
Yes, sir.
Or someone was writing.
No, sir.
All right. What's the time?
10:20.
Should we talk about application or you want to go for break?
Wanna go with it?
Should we talk about application or you want to go for break?
If you want to go for
Sir.
Yes.
yes, sir.
Someone said, sir, you didn't say anything.
Well done, sir. Please, we want to go for break.
Then when you come, all right, hold on, let me end the session. Hi guys, so this will be the end of the session. In our next lecture, I will speak about application of geometric progression. As a matter of fact, that will end sequences in the series. The next thing I will touch on is theorems in circles, because it's a very important topic. Whether you like it or yes, you'll be examined for this coming of deck. All right, bye.